Okay, this is going to be part 5 of our devices modules. In the last module, we added in our wash device. We copied pasted the device template. We instantiated it inside of the robot function block, and then we customized the logic for the wash function block. Added a wash data type, and we made sure that the parent device was issuing start commands and properly um, waiting for the appropriate status to come back. And then yeah, we closed that video out. So in this video, I intend on walking us through how to create device level errors and warnings. And in addition to that, you know, by showing you that, hopefully we kind of learn a little bit about how the mechanism of triggering device errors and warnings works, where it's collected at in our system level fault monitor function block, and then um, how the associated parent device would react if the child had a fault, and how the wash device itself would react. So get to kind of see a little bit of that here. So um, I think what I want to do is, remember we added that fake input to the wash, that wash input. We wanted to detect the level of the water. Okay, so that water level switch, we're looking for that water level switch to be on or okay if there's enough water in our tank. If there's not enough water in the tank, that'll be false. So anytime that occurs, basically we want to trigger an error. And so I think the only time that I would want to maybe analyze and see if we did have enough water is either while we're in an idle step or while resetting. So we could check it in two places. So maybe just for now, for the sake of um, example, I'll just show you maybe how we would look for that while we're resetting, and then we'll see how that reaction, see what would happen in that reaction case. So first off, I'm just going to start by building this Codesys program. We made a lot of changes in the last video. I didn't end up recompiling it. I just want to make sure we don't have any errors. And we don't, so we're all good. So let's go back to the wash function block. And again, we have this reference to this input, wash inputs. And so in step number 60, when we're resetting ourselves, basically what I'm going to do is I'm going to say checking water level. So while we're checking the water level, basically what I'm going to do is I am going to look at water level switch OK. And actually I'll do the negative of that. So if our water level switch is okay, we'll switch to idle. If it's not okay, we'll trigger an error. So if we come down to our toolbox here, POUs, we want to use this record device fault function. This is going to allow us to conveniently record a device fault. So the device fault data in this case, this record device fault function, it can be either an error or a warning, and so we need to tell the function, what data structure do we want to affect. And so for us, we want to affect the errors. Okay. So for errors, For errors, we want to add that in here. So yeah, basically this errors, dev.errors is of data type device fault data. And so we're passing in that data type. And if we go look at the definition of device fault data, again, we have this list of faults. It's only 3 long, and then we have a errors present status, and then children errors present status. So all those things are being managed and set inside of a record device fault function. Basically, this thing just says, okay, if the code that we pass in, so for us, we're going to pass in a number, like let's say 3. So if that code, as long as the code is greater than 0, then we're going to say, okay, that device fault data dot present is true. We're going to set that to be true, and then we're going to add, basically we're going to add in that code into our array, to our device fault code array. And there's some other logic in here that handles logging. There's a function in here for auto resetting. So we may have a fault that we want to reset automatically. We don't want to have to wait for the operator to have to reset it. And so you can designate that here with this auto reset. So in our case, I don't want to auto reset that fault. So I'm going to say false there. Really, auto reset is really more intended to use for warnings. But for us, the error code, the way that I've been managing error codes is device dependent. And so I want to create a new enum called wash.errors. Okay. So we want to define this in our wash data type. So we want to go here, add a DUT wash errors. And this is going to be an enumeration type. We're going to add that in there. And the error code of 0 would correspond to no error. And then, so for our first error, I like to be clever about how I name it and very consistent and obvious. So what are we doing? We're checking the water level. So if the water level is not okay, then that's what we're going to call this error. So water level not okay during reset. Okay, so that's simple as that. All right, let's just water level not okay. We can just distill it down to that. That's fine. So we give it a unique enum number, come back to wash, and now when we type in wash.errors, it gives us those enum types. Okay, so there. A value of 1, error code of 1. So if this subrung right here becomes true, when this is activated, record device fault, it's going to take this error code and it's going to populate it into this error, this device fault data here, and then it's going to set that errors present bit on. And it's not going to duplicate the same error code. So if we're sitting in this step for several steps, and this keeps going true, record device fault function is not gonna fill that device fault array with the same error code. So it's pretty handy dandy. So if we were actually resetting and if the water level switch in fact wasn't true, then what we would do is the record device fault function again would record the fault and record that error code, and it would set that dev.errors.present bit to be true. So while we were in this rung, this would basically become true. Okay? And so just so we're just extra careful, just make sure we don't transition to idle. But the yeah, if there's an error, we're going to jump to aborting, and basically we're not going to do anything in aborting other than we're going to end up slingshotting from aborting. Let's just chase it through for funsies. We're going to go to killed. Once we're in killed, we're not going to be in an instant kill. You know, instant kill is related to the e-stop status. We're not being told to be killed at this point in time. So we have an error, so we're going to jump to faulted. So ultimately, we're going to end in this faulted state right here, and we're going to sit there until someone clears those errors, right? So operator comes to the HMI, says, oh, there's a washer has a fault code, so let's better fill the water. And if they don't fill the water and they reset it, well, guess what? They're going to come right back to faulted. So let's look at how that's reacted to in the robot logic. So anytime we transition from inactive to resetting, well, guess what? Our parent is telling us to reset. So let's see what happens in the robot logic. So if we come to the robot logic, let's come to its resetting steps. So we come to resetting robot controller, no, resetting robot controller, resetting deburr, resetting wash. Okay, resetting wash. So in resetting wash, we issue the reset command, and we're waiting for the robot to go to idle. If the wash ends in is faulted, then we're going to actually go to an aborting step and fault ourselves out. Okay, so we saw already that if the washer encounters that error, it's going to terminate into this faulted case. And so basically this reaction is once we detect that the washer goes to faulted, we're going to abort ourselves. And we would abort. So let's see what we're doing here. So we would abort, and then we would issue in our abort these kill commands. So in this kill command, we're killing the deburr, the washer, and the FANUC controller, and we're waiting for all those to be killed. So if we look at our washer, we would actually transition from faulted to killed, and we're doing that here. So in this kill command becomes true, instant kill becomes true. We look inside of our device state engine, and we have some logic in here that says anytime we have a kill command come on, and we're not killed, that we're going to run ourselves into the killed step. Okay, so we're going to set, or actually, sorry, to the aborting step. But aborting will end up in, it'll terminate to killed. So ultimately the washer will jump from faulted to aborting. In aborting, it'll come back to killed, and in killed, it'll stay there until this kill command is dropped. And so in robot, it's waiting for that killed command to become true. Once it sees that, then it will jump itself to its killed. So it'll go from aborting to killed. So in killed, we're going to sit in killed until, and we're going to jump to inactive, and I have a feeling in inactive, if our children, which in this case is the washer, has a fault, then we'll jump to faulted. For good practice, I'm going to just include this. I need to update this logic. Children present. This doesn't really matter, but I'm going to add it in here just to be consistent. So we're going to jump to faulted. So if we're faulted, then guess what? The person who told the robot to reset the conductor, he's going to go to faulted. So when the conductor faults, let's see, resetting, resetting robot. The robot is faulted. then we're going to jump to faulted. There's a slight inconsistency with that. I should probably be jumping to aborted, but I think it's probably okay. Yeah, I don't want to change the logic for the conductor just because I I can't test this right now, but if I was still connected to the machine, I would probably likely refactor this to just go to the aborting step. But I'm not going to do that right now. So it's probably already happening somewhere up here. Instant kill. Yeah, it's already happening anyways. If you're resetting, yeah, so it would have happened. It happens here. We're going to go to aborting because of this logic. So no worries. Didn't need to add it in. This is kind of, this sort of subrung is kind of useless, but I'm just gonna leave it in there. I don't, like I said, I don't want to like change something that I can't test right now. But there's really no harm in what's going on there. It's pretty much see it's gonna go back defaulted. So that is kind of the reaction of error triggering. So the way that we detect if so like let's say we're back in the robot, and the way that we detect if the child has an error is I have this little rung at the bottom, this check children errors function. Basically, we're just looping over our children array and then checking to see if there's any errors present. And if there is, then our child has errors. And we set that function to be true. And the output of that function is dev.errors.children present. So that is error triggering. So we saw how to add an error in there. Now I'm gonna go in here since we don't actually have that water level switch, okay. I can do two things. I can ignore this in the logic, which probably is a better idea. I was just gonna fake this signal on, but let's just go ahead and just, this is a good time to use the machine.utilities always off. So basically we'll never trigger an error here. And then we are going to add an OR statement, and we're going to use the always on. So bypassed. So we're not using that water level switch. All right, but let's say that at some point while we're running, it could happen that the water level sensor, as the robot's processing 100 parts, the water levels may go from, maybe during resetting it was okay, but maybe through the course of washing it, you're losing water, you're blowing it out, and maybe it just transitions from good to bad over that course of like 50 parts. Rather than killing the entire process and faulting out everything, by triggering an error for low water level, we could actually just trigger a warning. So a warning will say, hey, the water level's getting low. It's probably okay, right? Like when we reset, anytime we reset, we're checking to see if it's okay, and if it's not, we error out, right? So it's probably just marginally not full enough, and we don't need to halt production for that simple, stupid reason. So let's trigger a warning instead. And we already mentioned that we don't necessarily want to trigger that warning while the robot is like actively dunking the water in the parts and is like swishing things around. So we need kind of a way to um, we need sort of a good way to handle that case. So the easiest thing that we could probably do for ourselves is we could add a signal debounce to that input. So, and we'd put something really large for the input. So down here, let's I don't have a super consistent area where I'm doing input debouncing. I know I do that a little bit in the IO map. I think there's one case where I do it there, but I think right now I feel comfortable just adding it here. So I'm gonna go down and I have this helper function called debounce. I think it's called debounce signal function block. So it's gonna try to add a debounce function block for me. So I'm gonna add that in there. Signal is going to be that water level switch. So this is an in-out variable type. So it's going to pass in this input, and it's effectively going to affect what the value of I water level switch. It's no longer just going to be whatever the SMC input state is. It's now going to be affected by this debounce signal function block. I'm not going to go into the details on that, but basically it's going to debounce it. So our delay off is the amount of time we require the sensor to be off before we allow this like sensor to go from a true state to a false state. So if you think about the robot washing process, that probably takes 20, 30 seconds. So we could probably be safe and just add in a time of 1 minute here for the delay off. For the delay on, we don't want to delay it on. If the sensor is good, then we can just say this is effectively saying how long do you want to enforce the sensor signal to be on before we consider it to truly be on. I don't think there's any harm with just having it be on full time. Or having it be on anytime the sensor input truly is on. Signal description is just a string. This is the wash water level switch. Level, okay, there. Jitter warning. Here we could actually create a warning for ourselves, and maybe I don't anticipate this. It's going to be jittering, but we could. Here we can say something like wash level, wash water level, okay jitter. And so if we do that, we have to jump down into source, wash, data types, add a data type, wash warnings, and it's going to be an enumeration. No warning. And then what was that? I don't remember what we called it. Wash water level, okay. Sensor jitter. What a great name. So let's add that. Don't care. Equals 1. So when we're adding warnings and errors, we also have to be cognizant that we need to add those into our into the user interface. So I'll maybe show you how to do that in a later episode. So I know we're gonna add another one in here called wash water level not okay warning. So I'm just gonna go ahead and add that one in there. I know we're gonna use that. Okay, so we've just debounced our okay. And you know what? I'm actually going to create a sub rung here. And I'm gonna say that I'm only going to respond to that warning if the device is um, uh, hmm, no, I'm actually just going to get rid of that. I have a feeling that sensor is going to jitter naturally, so I'm going to just get rid of it. Let's just get rid of that. Gone. You can just leave that empty. Okay, so we still want to debounce the signal, but don't want to do it there. Okay. All right, so probably the area that we want to check for that warning is going to be let's say anytime. So we're going to add a new rung in here. We're going to call it water level warning. And set warning if water level is low. So again, we're going to want to put in the reason why I'm doing this kind of asynchronously is I think it might just be easier for us to do it that way. So we want to record this device fault. And so I want to do it anytime our wash device is probably idle, paused, or running. Okay. So if we're not idle, paused, or running, I don't want to look at it. And I definitely don't want to set a warning if we're resetting and it's the switch is low. It just looks bad if you issue the same warning that you have for an error. So I try not to do that. I try to, it's either one or the other. So yeah, we'll only be looking at the water level and issuing a warning if we're either idle, paused, or running. So it's good use of this bit. And I will create I actually want to auto reset this warning. Dev.warnings. And then the error code is going to be wash warnings dot wash water level not okay. Sweet. Why don't we refactor that to say water level not okay? Water, let's see, refactored it for us. Isn't that nice? Okay. So set warning if water level's low. So what we're basically saying is anytime we're idle, paused or running, and if the water level switch is not okay, so water level switch not okay, and we're in idle, pause, running, then trigger that warning. Okay. And again, we're hoping to accommodate the sort of splishy, splashy, that water level switch truly that input may go on and off frequently while the robot's swashing around the parts. But if we put a long enough delay off on it, so if it was already on and then it's swashing around, it's probably likely the sensor is going on and off multiple times while it's swashing, and then eventually the water will settle and it'll come back on. We're not going to falsely trigger a water level warning. But if the water is truly low and it's been low for over a minute, then we'll trigger this warning. And basically, while we're actively running the robot, it's deburring parts, loading CNC, unloading, washing. We're not going to fault the entire system and air it all out and force somebody to come do some intervention. We'll just trigger a warning instead. A little, typically the little yellow stack light will come on and off, and somebody can see that something's not quite right. And if they have time, they can refill the water level. They can stop the machine and refill it, in a timely fashion. And if not, that's okay too. So that basically covers this water level switch warning. So we kind of got a taste of how errors and warnings are triggered at the device. Now let's go just take a peek and see how we're listening to those in our system level function block, which is called fault monitor. So if we look at fault monitor, basically in the fault monitor, we are collecting, so for our device count, we're going to basically do a for loop over our device array. And if there's any errors present, then we're going to collect those errors into this fault code array called machine.errors list. And we do the same thing for warnings. And then anytime if someone hits the clear faults button, then this becomes true right here. This code gets exercised, and we basically clear the lists for everything. And okay, for a second so there's an area in our code where we listen to like our parent and they're like clearing faults, but we also just go ahead and we do a for loop over the entire device list here, and we just clear the errors and warnings anytime that clear faults button is hit on the HMI. So that handles, again, it goes through the device, each and every device in that device list, and it clears out all the errors and all the warnings. So that's pretty much the fault monitor. It just basically collects all the errors and warnings from each individual device, puts it into these machine level errors list, and then clears it here. So that's pretty much it, and thank you for listening.